Okay, welcome back to Math 20-1. We're going to do a video lesson today. So we're on page 449, and we're starting Unit G unit. And we're going to talk about absolute value of a number. So we start off with a definition. And it says, the absolute value of a real number can be defined as the principal square root of the square of that number. So basically it's going to be positive, principal positive. So the absolute value of 6 would be, so if I take the square root of it, the square of it, and then square root, so square root of 6 is 36, square root of 36 is 6. Do the same thing as negative 6. Squaring negative 6 gives me 36 still, which square root of 36 is 6. Okay? So for a real number, so no matter what the number was, the absolute value is written as absolute value of A is just with those bars. Okay? And so there's the two examples there with 6s. So no matter where you go on a number line, it's the absolute value is regarded as the distance of that number, okay, from 0. So negative 6, even though it's in the negative side of the number lines, it's still represented by 6 units. So if I were to walk backwards 6, I'm still walking a distance of 6 something. Just like I were to walk forward 6 of something. Okay? So the absolute value of a number will never be negative. So this is going to have some, I guess, repercussions when it comes to graphing, etc. But first off, simple example. So if we were to evaluate, so that means, what is this equal to? So if I were to do the absolute value of 3 is just 3, just like the absolute value of negative 3 is 3. Okay? This one, because the negative sign is outside, this is still going to be a negative. Okay? Now, this part will become positive, but you still have a negative outside, so this is still negative 8. This is going to become positive 7, so 7 plus 7 is 14. 1 minus 5 becomes negative 4, which then becomes positive 4 because we took the absolute value of it. Okay? This one right here, so the square root of 81 is 9. The absolute value of negative 9 is positive 9, and then I've got my lone negative sign out there. So that will just turn it into negative 9. So nothing too crazy there. We are now going to look at, so the first couple of questions in the assignment are just these types of questions, being able to evaluate them. Okay, so now we're going to bring in the graphs. Okay, so we're going to look at functions. So the function f of x is equal to the absolute value of x. And we're going to look at g of x and h of x. G of x is equal to positive x, h of x is equal to negative x, and their graphs respectively are just going to be y is equal to x, y is equal to x, y is equal to negative x. Ooh, bless me. Okay. And y is equal to negative x for the h of x. So sketch and label each graph on the grid below. So if we have the positive x there, if you were to just put in, so your y1 is equal to x and your y2 is equal to x, negative x. Okay, you're going to get two graphs that I'm going to try to draw carefully because I don't have a ruler. Okay, so essentially this has a slope of 1 and a y-intercept of 0. Okay, this has a slope of negative 1 and a y-intercept of 0. So it's going to go the other way. So why don't I just color code this? Y'all know how I feel about my color coding. Okay, so this is my h of x is equal to negative x, g of x is equal to x. There we go. Okay. So now, looking at number 2, consider the function of f of x is the absolute value of x. So whose graph has the equation y is equal to the absolute value of x. Complete the table of values. So if I were to put in all these x's into that x there, so negative 5 into the absolute values is going to be positive 5. Okay, negative 4 into the absolute value will be positive 4. So essentially they're all going to be the same number, just positive. Okay, so then complete table of values done. Now we need to plot the points. So x and y, so negative 5 and 5 is right there. Negative 4 and 4, 3, negative 2, There we go. So we get this V shape. So, and it does tell us to join the points. So with our ruler, or a steady hand, we join the points. Okay, so overall, we know that if we've got an equation of just like a straight line, it's just going to look like that. If we've got a quadratic, it's going to look like that. Okay, trying to think of other things that we've looked at graphing. Those are the two main ones. But now that we've done the absolute value, okay, that's the V. So quadratic is U, absolute value is V. Okay, so explain the similarities and differences between the graphs on the two grids. Okay, so first off, when y is greater than 0, when y is greater than 0, okay, so that would be in this section right here. So do I have a yellow highlighter somewhere? Dang, I don't know where it is. Okay, well, I'm just going to lay this. Okay, so when y is greater than 0, those graphs look the same as the combined graph. Okay. Okay. And then when y is less than 0, okay, so down here or here, the graph of the absolute value has no points. Okay, so those are the similarities and the differences. Okay, so the graph of the absolute value contains two straight lines. State the equation of the line in quadrant 1. Okay, in quadrant 1, so just the reminder, 1, 2, 3, 4. So quadrant 1, okay, that represented y is equal to x. Okay, and then in quadrant 2, that one's the same as y is equal to negative x. So we can see from this number 4 that the equation y is equal to the absolute value of x can be written in two pieces with different domains for each piece. Okay? So domains, we know anything that has to do with the x-axis. Those are our independent or our inputs. So complete the following to write the absolute value function as a piecewise function. So piecewise function just has to do with the fact that we're breaking it up into the two. Okay? So f of x is equal to x if x is greater than or equal to 0, and it's equal to negative x if x is less than 0. Note that we put the positive x with the equal to 0. Okay? And then recall from the definition of the absolute value of a number on that first page there, that the absolute value function could also be written as this, the square root of x squared. I'm going to highlight that. Okay, the absolute value can be written like that. Okay, so that was us investigating the function of the absolute value by looking at just y is equal to x and y is equal to negative x. Okay, so now we're going to define the absolute value function of f of x is equal to the absolute value of x. Alright, so we did just state this. So f of x can be defined as all this. Okay, we just said that. Notice that when x is a positive number, the absolute value of x is x. When x is a negative number, the absolute value of x is equal to negative x. Okay, so this helps us when we're doing our graphing, etc. Okay, so now we're going to put something else in here. Okay, so in the long run, this kind of thing right here that we're subtracting from x, we're going to call it just generally h, and we'll talk much more about when we subtract something from x in grade 12. Okay, so consider the functions. So g of x is equal to x minus 3, and h of x is equal to negative x minus 3. So note the negative outside there. Okay, and so then those are the two graphs respectively. So completing the table of values, so then we would just substitute all of those in for x. So negative 4, and negative 3 is going to give me negative 7. I should say subtract 3. Negative 3 subtract 3, negative 6. Negative 2 subtract, okay, well we see the pattern here. We're just going down by ones. Okay? Now for this one, we're flipping our sign because we're going to put negative 3 subtract 3 is negative 7, but then we're going to have negative 7, which is going to be positive 7. Okay, and that's going to do the exact same thing to all of these. It's just going to flip the sign so we can quickly fill out those table of values. Okay, done. So now we need to plot the points and then join the points. Oh, and extend the graph, so that means like put the arrow on it. Okay, so plotting these points here, and I should have color coded it, but oh well. Okay, negative 7, oopsies, my bad, negative 4, negative 4, negative 7, oh, I did something wrong there. Oh, dang. Here's the whiteout. Good enough. So then 0. Where's my 3 and 0? Good. Okay. So that's the first one. Oh, I do have a ruler. Okay. So we see that they intersect at the x-intercept of 3 and 0. Okay. Oh, that was a horrible line. Yeah. Oh well. Okay. So we plotted, we joined, we extended. So now you might be noticing what's happening when y is equal to, or sorry, greater than or equal to 0. We've got that V shape again. Okay? So we are now going to take the absolute value of these two things. Okay? Or actually, just kidding, just the x minus 3, 1. Okay? And we're going to complete the table of values. So the negative 5, so negative 5 subtract 3 is negative 8, but then when I take the absolute values of it, it's going to be positive 8. Okay, and then I essentially just have the same numbers as I did before here, except for it's the absolute value. So 7, 6, 5, 4, 3, 2, 1, 0, -1, -2. Okay, so there's all my y values there. Okay, so so then I am going to, so I've done that. Now I'm going to plot the points, join them, extend the graph. 5 and 8 is like off the charts here. 4 and 7. Okay, so there's my V shape again. It looks very similar to what I had over here. Okay, one thing you'll notice, the vertex is at 0 and 0 here, whereas my vertex here is at 3 and 0. Okay, so we're going to talk about that 3 and that 3. Okay, so I guess we didn't talk about it. Okay, weird. So we're going to talk about it now. So essentially, whatever I subtract from my x there, it's just going to shift the graph. Okay, so the very like base. Okay, so when h is greater than 0, it's going to move to the right. If h is less than 0, it's going to move to the left. So for example, we had x minus 3. Okay, well h was just equal to 3 because there's supposed to be a negative there. If we had x plus 3, that's actually x subtract -3. So that's why when h is less than, it's going to move that way. So this is just a little bit of a precursor to what you're going to see in 30-1, but just so we can kind of like lay the groundwork there. Okay, but it's pretty easy to see that -3 and then we moved over. Okay, so let's answer the question 3. So the function is written below as a piecewise function again, but the domain for each piece has been omitted. Okay, so same thing here. Now instead of the greater than or equal to 0 and then the less than 0, well, we've got 3. So this is going to be greater than or equal to 3, greater, oopsies, dang, less than 3. Okay, so that is the piecewise function for the domain. Okay, all right. Explain, so we got 2 more for this specific question. Explain how the equation of the second piece can be determined from the equation of the first piece. Okay. So, the equation of the first piece, the second piece, the equation of the second piece is just the negative of the equation of the first piece. Equation of the second piece is the negative of the first piece, because the second piece was y is equal to -x minus 3, and the first piece was y is equal to x minus 3. Okay? And then explain algebraically, without using a graph, how the domain for each piece could be determined. Okay, so if you were to find the 0, okay, or the x-intercept, so 0 x-intercept, if you were to find the 0 of the absolute value function, and then let's just call it p, so the 0 of the absolute value function, okay, that divides the absolute value function into 2 pieces. Okay, that divides, or call it 0, sorry, divides the absolute value. Into two pieces with domains of x equal to greater than or equal to p and x less than p. So this is the general statement that is true for all absolute value functions. So the 0 of the absolute value function, so we'll just call it p, divides the absolute value function into two pieces with domains of x is equal to or greater than p and x is less than p. So our piecework functions, that's a big part of our absolute values. So every absolute value function can be defined in pieces. The absolute value of a quantity will always be the same quantity if the quantity is positive and the opposite quantity is negative. Okay? And then writing an absolute value function in piecewise form is an integral part of determining the solution to absolute value equations or inequalities, which we'll talk more about inequalities. That was introduced to you, I think, in Math 9. Okay? Okay, so let's do a example. And actually, yeah, it's the last example before we're done. Okay, so express f of x is equal to 3x plus 2 as a piecewise function. Okay, so we look at f of x and we split it up into the positive, all right, and then the negative. Okay, so you literally just put the negative in front. You could also, so just a side note, you could also put this as negative 3x minus 2. You could put that there, like just distribute that negative sign, that would be fine. Okay, and so then you just take this whole thing, 3x plus 2 greater than or equal to 0, 3x plus 2 less than or equal to 0. Okay? So I'm going to give you a few minutes to try this one. Okay, so the absolute value expression, so same thing, and let's just call this g of x. Okay? And see what you get there. Okay, I think that's enough time. It's hard to do it. Can't look at your faces to see how you're doing. So there's the positive form and then the negative form. So I'm just going to write it by switching the signs there. Okay, and then we would do that greater than or equal to 0 and that less than or equal to 0. Okay? And so this would be kind of the standard, the acceptable standard that I would want. If you wanted to take your game up a notch, then we're going to have to simplify this a bit. Okay, so then we would write, so the first part's the same. Let's do this one here too. Okay, so we don't want this whole thing, we want what is x. X. Okay? So then I would move that 2 over, so that's going to become negative 2, and then I would divide by 3. So x is going to be greater than or equal to negative 3, and then less than or equal to negative 3. Negative 2 over 3, sorry. Okay? And then same idea here. So here I'm going to move the x over. First part stays the same though. So that's going to be, so if I move the x over and solve, there, okay? And just a side note, we do usually want our variable on the left side. So I just like to move like whatever's negative over, because remember, if you have to move something over and then you have to switch the sign, you just have to, or like switch this sign, then you have to remember to switch that sign. So x is going to be less than or equal to 4, x is going to be greater than 4. So that's how we would, if we wanted like 100% kind of thing, we would write it that way, but I would accept this on a test. It's saying the same thing. Anyway, okay, so write it in this form. Definitely, like, feel free to start off in this form and then simplify, do it in the 2 steps, or, you know, if you feel like you can just do this in 1 step, that's fine too. Okay, so you guys can work on the assignment 1 to 11, and I'll see you later.